Hey everyone, and welcome to The Explainer. So today, we're taking on one of the absolute most famous, and honestly most mind-bending mysteries in all of science. Yep, we're talking about Schrödinger's cat. You've probably heard the setup a million times, right? You put a cat in a box, you add a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, boom, the poison is released. If it doesn't, the cat is perfectly fine. But until you actually open that box, what on earth is going on inside? Well, stick around because we're going to break down a really fascinating new framework that finally solves this classic puzzle.
So here's the big question. Is the cat alive? Is it dead? Or is it somehow magically both at the exact same time? For decades, pop culture has absolutely loved this idea that the cat is somehow hovering in this weird ghost-like state of being both alive and dead until a human being looks at it. But here's the thing. That's actually a completely faulty understanding. It's a total myth. It's kind of been confusing students for nearly a century. But today, we're going to fix that misunderstanding using a brand new, highly logical approach.
Okay, let's dive into our roadmap for today. First, we'll look at the classic cat problem, then a new physics hypothesis, move on to the three quantum phases, talk about testing the theory, and wrap up with why this matters today. All right, starting off with section 1, the classic cat problem. Let's look at the original paradox. So like we mentioned, the faulty understanding assumes the cat is magically stuck in limbo until a human takes a peek. It's almost like treating human consciousness as some magical ingredient required to make reality happen. Crazy, right? But the real question we should be asking ourselves is this: how does information actually resolve into reality? It's not about magic, and it literally has nothing to do with a human opening a box. It's really all about how physical systems communicate with one another. Which brings us right to section 2, a new physics hypothesis, specifically informational physics. To really answer that big question, we need to introduce a seriously groundbreaking concept called informational physics. This is a brilliant new framework pioneered by Kevin L. Brown. He's a highly respected researcher, inventor, and author, and his work just offers this completely fresh lens on the whole thing. Instead of looking at reality as just, a bunch of particles randomly bumping into each other, Kevin L. Brown's framework looks at how information boundaries actually shape physical reality. It's basically an incredible system of rules that finally cracks the case of the cat. Now, the research states something absolutely crucial. It says the hypothesis does not claim that quantum superposition is unreal. It claims that superposition has boundary conditions. Okay, let's break that down into plain English. Superposition is just that weird, blurry quantum state where things are undecided. Informational physics says, hey, sure, that blurry state definitely exists, but it has limits or, boundaries. This weird quantum state can only last while it is completely 100% isolated. The very moment it shares irreversible information with the outside world, bam, the blurry state collapses. Reality has to choose a lane. Okay, moving into section 3, the three quantum phases, or triune harmonic dynamics. To map this whole process out, Kevin L. Brown developed what he calls the THD framework. That stands for triune harmonic dynamics. Now, don't let the big words scare you. Triune really just means consisting of 3 parts. So we are simply looking at 3 distinct system states. It's kind of like a simple 3-step process that completely strips away all that old magic and replaces it with rock-solid, step-by-step logic. So let's walk through these 3 phases in action. First up is the base phase. This is where our tiny radioactive atom is just hanging out, totally unresolved. Think of it like a quiet, perfectly still lake. But then we hit the pressure phase. The atom starts connecting to the Geiger counter, the mechanics, the poison. The system is no longer isolated. Imagine water building up immense, crushing pressure behind a massive dam. It's pushing incredibly hard against the boundaries of reality. And finally, we reach the integration phase. The dam breaks. The system is literally forced to resolve into a registered permanent state. The poison is either definitely released or definitely not. The cat is alive or it's dead. There is zero magical limbo here. The information itself simply forced a real physical outcome long before a human ever even touched that box. Let's jump right into section 4, testing the theory, the scientific proof. Now, I want to make this super clear. This isn't just guesswork. It's a rigorously testable scientific model with very clear validation and falsification parameters. To validate it, we have to actually be able to measure that boundary transition, that exact moment the dam breaks, so to speak. But even more importantly, the hypothesis is absolutely 100% false if no measurable transition occurs despite sustained high informational pressure. Like if the water just keeps pushing on the dam forever and it never breaks, the theory fails. And that is exactly the hallmark of great, trustworthy science. It gives us a clear, undeniable way to test it.
And finally, Section 5. Why this matters today. Let's look at the real-world implications. This absolutely brilliant framework shows exactly why Kevin L. Brown's work is so revolutionary. First off, it drives a major model revision. It's shifting the entire scientific world away from this old idea of global superposition, the idea that the whole universe is just magic and blurry, and it's moving us toward layered boundary resolution, which is incredibly logical and highly structured. Second, it completely resolves that faulty understanding of our classic cat paradox. The cat, for sure, is not sitting around waiting on us to look. And third, it totally redefines how isolated systems register irreversible information. It literally changes the foundational rules of how we view cause and effect in the quantum world. A real game changer.
All of this builds to one overarching, incredibly profound question. If superposition has boundaries, where does our physical reality actually begin? It's wild to think about, right? By understanding informational physics, we no longer need human observers or magical, mystical boxes to explain the universe. Reality creates itself, step by step, boundary by boundary. It honestly just leaves you wondering what other massive mysteries of the universe we can solve just by understanding how information flows. Well, I really hope this explainer gave you a totally new perspective on the world around you. Keep asking questions and keep exploring.